Let's solve another type of problem. So look at this one. X to the power of 2n minus y power 2n is divisible by x plus y. We need to prove this one. Alright, again, go with the particular logic what we used to do in all the previous problems. So first we start by taking, this is p of n, correct? And then we take for p of 1, isn't it? So first what we'll do, p of 1. So p of 1 is going to become x square minus y square, which you can write it as x plus y into x minus y. Clearly, x plus y into x minus y is divisible by x plus y because you have that x plus y, isn't it? So p of 1 is divisible by x plus y. Same way, if you take p of 2, this is going to be x to the power 4 minus y to the power 4. Again, you can write it as x square plus y square into x square minus y square. See that x square minus y square, you can again further write it as x plus y into x minus y. So basically what we get, we are going to get this as x plus y into something. Whatever you might have, but it is x plus y into something. So p of 2 is also divisible. Likewise, we can say that let p of k, which is x to the power of 2k minus y to the power of 2k, is also divisible by x plus y. Now, if we prove p of k plus 1 is also divisible, that's how you are going to do it, correct? And that's how we were solving all these problems till now. So, now p of k plus 1. P of k plus 1 will become x to the power of 2 into k plus 1 minus y to the power of 2 into k plus 1. Now, we need to prove that this is divisible by x plus y, isn't it? To do this one, first what you do, so you multiply this. In the sense, you're going to get this as x to the power of 2k plus 2 minus y to the power of 2k plus 2. Correct? Let's split it. In the sense, you can write this as x to the power of 2k into x square minus y to the power of 2k into y square. Correct? This is what we have. Now what we can do is, we are going to take common and we are going to do it. Alright, so let's solve this one. See, what we'll do is, we have to take out x plus y as common, correct? Some or the other way we need to do it. So what we can do, we'll try to add and subtract couple of things. In the sense, we can add and subtract y to the power of 2k, something like this. Fair enough? So here what we'll do, in this particular case, let's add and subtract y to the power of 2k. Okay, let me tell this again. We are going to add and subtract. So in the sense here, if you can say, so add and subtract y power 2k. Alright, now there is a reason why we are doing this though. So when you add and subtract, you are going to get x power 2k, correct, plus y to the, x power 2k into x square plus y to the power of 2k minus y power 2k into y square minus y to the power of 2k. Now, if you look at this, that x power 2k and y to the power of 2k plus and minus, those two will get cancelled. But then, of course, you're not going to cancel it. What I'm trying to tell is the equation is not changing. Equation is one and the same. Alright. Now, once you have this, then what we are going to do is we are going to group and we are going to do some manipulation here. Clear? So let's do what kind of changes we can make for this particular equation now. Alright. See, now what we are going to do is, here x square into x power 2k plus y power 2k minus y power 2k minus y square or y power 2k into y square, correct? See, now what we'll do is, Look at this particular equation here. See the equation what we have, x power 2n minus y power 2n, correct? Now what we can write is, we can write that x to the power of 2n, x power 2n, then minus y power 2n, we can write this as m into x plus y. Okay, so we can write this as m into x plus y. So what we can write here, we can take that as common and we can do it. All right. So what we mean by taking it as common and we are going to do it in the sense here in this particular term. All right. In this one, we can write in terms of m into x plus y. All right. So that's what we are going to write here. All right. Now what you have, x power 2k into this one, correct? So now what we are going to do is, we'll add and we'll subtract x square into y to the power of 2k. Okay. Now why we are going to do it, you will understand. See, we are going to do this one, add and subtract. That means you are going to have x power 2k into x square minus y power 2k into x square plus y power 2k into x square minus y power 2k into y square. Correct? This is what we have. Now in the first part, take x square common. So x square into x power 2k minus y power 2k plus y power 2k minus y power 2k into y square. See, once you have this, now y to the power of, sorry, x power 2n minus y power 2n, what you have here, see what we can write? We can write that as x to the power of, see, x power 2n minus y power 2n. This we can write it as m into x plus y. See, the reason is, if you look at, a couple of minutes back, we just proved that p of k is divisible by x plus y, correct? So we just proved it. Now, if p of k is divisible, or here, to be more precise, I would write this as k. I think, to avoid the confusion. P of k is divisible by x plus y. So if something is divisible by x plus y, we can write it as m into x plus y, correct? Like if you say, see, you know that 10 is divisible by 2. So we can write 10 as 5 into 2, isn't it? So a multiple of 2. Likewise, p of k, that is x power 2k minus y power 2k, is divisible by x plus y. So we can write it as m into x plus y. Now what we are going to do is, here we will write it as m into x plus y. That means x square into m into x plus y plus y power 2k minus this. So you will have, now multiply this one. M into x plus y into x square plus y power 2k into x square minus y power 2k into y square. Isn't it? Now, see, m into x plus y into x square. Keep it as it is. Don't change it. Take y power 2k common. Y power 2k into x square minus y square. Can we not write this as x plus y into x minus y? Right? So we are going to do the same thing. We write it as m into x plus y into x square plus y power 2k into x plus y into x minus y. Take x plus y common. You will get x plus y into m x square plus x minus y into 2 power k. Sorry, y to the power of 2k, isn't it? My bad. So it's not 2 power k, it is y to the power of 2k. Correct? So what do we have? We have p of k plus 1. See, p of k plus 1, that value is this whole thing. Now, it's a multiple of x plus y because x plus y into anything is a multiple of x plus y, correct? So, what we are going to have? P of k plus 1 is equal to this. That means this implies P of k plus 1 is divisible by x plus y. If P of k plus 1 is divisible, therefore P of n is divisible by x plus y. So this is basically the proof what we are looking at. Clear? So this is another type of problem. Fair enough? So these are the type of problems what you have in this particular chapter of mathematical induction.